There are several potential reasons why ground fault circuit interrupter, or GFCI, outlets trip when used with hot plates, even if the hot plates are not grounding out. Firstly, overloading is a possible cause. Verify that the hot plates are not drawing more current than the circuit's rating. An ammeter can be used to measure the actual current consumption. Secondly, defective hot plates could be the issue. Check each hot plate for internal electrical faults that might cause a ground fault. Thirdly, moisture or spills near the outlets or hot plates can create a conductive path, leading the GFCI to trip. Ensure the area is dry and clean. Fourthly, the GFCI outlet itself may be defective or damaged. Test the outlet with the GFCI tester to confirm it functions correctly. Fifthly, reverse polarity in the electrical wiring can cause GFCIs to trip even without a ground fault. A multimeter can be used to check the polarity of the outlets. Sixthly, grounding issues can affect GFCI operation. The GFCI relies on a proper electrical ground to function. Inspect the grounding wires and connections for damage or loose connections. Seventhly, some GFCIs can be overly sensitive and trip unnecessarily. Consider replacing the GFCI outlet with one that has a higher sensitivity setting. Eighthly, loose wiring connections can create high resistance and heat, which can trigger the GFCI. Ensure all wire connections are tight and secure. Ninthly, electromagnetic interference, or EMI, from nearby equipment, such as motors or transformers, can interfere with the GFCI's operation. Try moving the hot plates away from potential sources of EMI. Some recommendations to address these issues include isolating the hot plates by using a dedicated circuit to prevent overloading. Install a GFCI outlet with a sensitivity rating of 5 mA or less. Inspect the electrical wiring and ensure all connections are proper and the grounding is intact. Use an ammeter to confirm that the hot plates are not drawing excessive current. If the GFCI outlet is defective, replace it with a new one. Also, consider using a circuit analyzer to evaluate the electrical characteristics of the circuit and identify potential issues, such as overloads or grounding problems. Addressing these potential issues methodically should help resolve the GFCI tripping problem. To elaborate on overloading, it's crucial to understand the total load in the circuit. A standard 15 amp circuit at 120 volts can handle a maximum of 1800 volt amps. A 20 amp circuit at 120 volts can handle 2400 volt amps. If the hot plate draws 11.3 amps at 120 volt, it consumes 1356 volt amps. If other devices are connected to the same circuit, their combined consumption must be considered. Exceeding the circuit's capacity will cause the breaker to trip, but even approaching the limit can cause the GFCI to become unstable and trip. If the hot plates are close to the maximum amperage, consider using a separate dedicated circuit for the hot plates to prevent overloading the existing circuit. Inspecting the hot plates, pay close attention to the power cords and heating elements. Look for any signs of damage, such as cracks, fraying, or exposed wires. Use a multimeter to check the resistance between the heating element and the metal chassis of the hot plate. A low resistance reading indicates a potential ground fault. Even small amounts of moisture can create a path for current to leak to ground, causing the GFCI to trip. Ensure that all surfaces around the hot plates and outlets are clean and dry. Avoid placing the hot plates near sinks or other sources of water. If spills occur, clean them up immediately. When testing the GFCI outlet, use a GFCI tester, which simulates a ground fault and verifies that the outlet trips as expected. Insert the tester into the outlet and press the test button. The GFCI should trip, cutting off power to the outlet. If the GFCI doesn't trip, it is likely defective and needs to be replaced. Reverse polarity can occur if the hot and neutral wires are swapped at the outlet or in the wiring. Use a multimeter to check the voltage between the hot and neutral slots. It should read approximately 120 volts. Then check the voltage between the hot slot and the ground slot. It should also read approximately 120 volts. Finally, check the voltage between the neutral slot and the ground slot. It should read close to 0 volts. If these readings are not correct, there may be reverse polarity or other wiring issues. The grounding system ensures that any fault current has a safe path back to the electrical panel, tripping the breaker and preventing electrical shock. Inspect the grounding wires for any damage or loose connections. Ensure that all metal parts of the electrical system, such as outlet boxes and conduit, are properly grounded. Some GFCIs are more sensitive to ground faults than others. A standard GFCI trips when it detects a ground fault of 5 mA or more. However, some GFCIs are designed to trip at lower current levels, such as 2 mA. If the GFCI is tripping unnecessarily, consider replacing it with one that has a higher trip threshold. Loose wiring connections can create resistance, which generates heat. This heat can damage the wiring and insulation, increasing the risk of electrical shock or fire. Ensure that all wire connections are tight and secure. Use a screwdriver to tighten the screws on the outlets and breakers. Also, check the wire connectors for corrosion or damage. EMI can disrupt the operation of electronic devices, including GFCIs. The hot plates themselves may generate some EMI. Other sources of EMI include motors, transformers, and fluorescent lights. Try moving the hot plates away from these potential sources of interference. You can also try using a line filter or surge protector to reduce EMI. To further elaborate on the use of a circuit analyzer, this tool can provide detailed information about the electrical characteristics of the circuit, such as voltage, current, impedance, and ground resistance. It can also detect wiring errors, such as open grounds, open neutrals, and hot neutral reversals. A circuit analyzer can help you identify potential problems that may not be apparent with a simple multimeter. When using a circuit analyzer, follow the manufacturer's instructions carefully. Connect the analyzer to the outlet and run the test. The analyzer will display the results on its screen. If the analyzer detects any errors, investigate the cause and correct the problem. If you are not comfortable working with electricity, it is always best to consult a qualified electrician. Working with electricity can be dangerous, and mistakes can lead to electrical shock or fire. An electrician can safely and effectively troubleshoot the problem and make any necessary repairs. The National Electrical Code, or NEC, provides detailed requirements for electrical installations. Ensure that all wiring and equipment comply with the NEC. This will help ensure the safety and reliability of the electrical system. Consider NEC Article 210.8 regarding GFCI protection requirements. Also, NEC Article 250 covers grounding and bonding. In addition to these potential causes and solutions, consider the age of the GFCI outlets. GFCI outlets, like all electrical components, have a limited lifespan. Over time, their internal components can degrade, leading to malfunctions and nuisance tripping. If the GFCI outlets are several years old, consider replacing them even if they appear to be functioning correctly. The cost of replacement is relatively low compared to the potential safety risks. When replacing GFCI outlets, choose high-quality products from reputable manufacturers. Look for outlets that are UL listed or have other certifications that demonstrate they meet safety standards. Also, consider the amperage rating of the GFCI outlet. It should match the amperage rating of the circuit it is protecting. If the GFCI outlet is rated for less amperage than the circuit, it could overheat and fail. Another factor to consider is the type of wiring used in the science rooms. If the wiring is old or damaged, it could contribute to the GFCI tripping problem. Inspect the wiring for any signs of damage, such as cracks, fraying, or exposed wires. If the wiring is aluminum, it may be more prone to corrosion and loose connections than copper wiring. In some cases, it may be necessary to replace the wiring entirely to resolve the GFCI tripping issue. When working with electrical wiring, always energize the circuit by turning off the breaker at the electrical panel. This will prevent electrical shock. Also, use insulated tools and wear appropriate personal protective equipment such as safety glasses and gloves. If you are not comfortable working with electrical wiring, it is always best to consult a qualified electrician. Remember that GFCIs are designed to protect people from electrical shock. They are not designed to protect equipment from damage. If the GFCI is tripping frequently, it is important to identify and correct the underlying cause to prevent potential safety hazards. Here's a summary of key steps to troubleshoot GFCI tripping with hot plates. Firstly, verify that the hot plates are not drawing more current than the circuit's rating using an ammeter. Secondly, check the hot plates for internal electrical faults using a multimeter to measure resistance. Thirdly, ensure the area is dry and clean to prevent moisture-related tripping. Fourthly, test the GFCI outlet with a GFCI tester to confirm functionality. Fifthly, check for reverse polarity in the wiring using a multimeter to measure voltage. Sixthly, inspect grounding wires and connections for damage or loose connections. Seventhly, consider replacing the GFCI outlet with one with a higher sensitivity setting. Eighthly, ensure all wire connections are tight and secure. Ninthly, try moving the hot plates away from potential sources of EMI. And tenthly, use the circuit analyzer to evaluate the circuit's electrical characteristics. By following these steps, you can systematically troubleshoot the GFCI tripping problem and identify the root cause. Also, remember to consult a qualified electrician if you are not comfortable working with electricity or if you are unable to resolve the problem yourself.